Yeah, all right, let's go on. All right, we're in 10.4, hyperbola. And we're supposed to take the practice exam tomorrow, right? Is that true?
You're saying.
We were supposed to, but...
We better put that off till Monday, huh? All right, let's do that on Monday. We'll do the practice exam on Monday.
Part one, right?
Go over it Tuesday. Real exam is still Wednesday, Thursday. Yeah, let's do that. Yeah, so I'm going to put practice exam Monday. So let's put the practice exam Monday. We'll go over it Tuesday. The real exam is still the same. They have, exam 3. We'll do Wednesday, Thursday next week. All right, let's dive in. So hyperbola. So how do we, so this is the last one. This will be easy. It's just almost exactly like the ellipse. It's x squared over a squared, y squared over b squared equals 1. The only difference is? Minus in the middle instead of plus. Yeah, here's my little way of thinking of it. So if you only have one letter squared, like what if you have y equals x squared? That's a parabola. That only has one branch, right? If only one letter is squared and the other is not, you've only got one branch. If both letters are squared, you've got two branches, but there's two ways they could get together. They can get, if you have a plus, then they get together and they make a big egg, right? Like two branches connecting. But if you have a minus in the middle, they have a negative relationship. There's my little, now they turn away from one another. They have a negative, so that's a hyperbola. So if you have a negative in the middle, if that helps you, the two branches turn away from each other. If you have a positive in the middle, the two branches turn towards each other, and you have an egg shape, an ellipse. And if you just have one letter squared, not the other, you only have one branch, either up or down or right or left. So there you go. That's the whole chapter. Now the specifics. So, okay, so here, let me put this on a fresh screen. So, x squared, going back again, x squared over a squared minus y squared over b squared equals 1. That's the hyperbola. So we look over here now. There's two ways the hyperbola branches can go. If x is in the front, then the branches go right, left. They're on the x-axis. If the y squared is in the front, then the branches go up, down. They're on the y-axis. Does that make sense on that? So there's two ways the hyperbola branches can go, turned away from each other. They can go on the x-axis when x squared is in the front. Y is in the front. They're up, down branches. Okay, so we look at that picture right there. They are going right, left, right, left. So which one of these answers is possible? Well, not that one, huh? It's some kind of x squared in the front because the branches are hitting the x-axis, right? So it's either B or D. Now, which one is it? Yeah, now I need to tell you about those numbers underneath, huh? So let me help with that. So let me erase this. So we're down to B or D. We got to figure out which one. Okay, so now the numbers underneath are a little bit tricky. They have to do with making a dotted box. Let me show you about that. So basically, if let's just say maybe it's B, for example. X squared. Let me just show you how you would check if B is correct. If there's no number, I'm just trying out B. If there's no number underneath X, what's that means under there really? 1, right? So that's really 1. So this is 1 squared and 3 squared, just like we did for the ellipse, remember? If that was a plus in the middle, if that was plus, this thing would be an egg shape, an ellipse. You would know just how to graph it because you did all your homework perfectly yesterday, we'll assume. And so, how does it, don't shake me off. No, don't lie to me. Say yes, Mr. Hare. Please, tell me sweet little lies. All right, so we'll go on from here. So, if this was an ellipse, how would we graph that ellipse? What would the 1 mean? Being underneath X. Right, left, 1. Yeah, just go right 1, left 1. Boom and a boom. And then what would the 3 squared, 9, under y? That's up 3, down 3, right? 1, 2, 3, 1, 2, 3. So we'd have a dot here, a dot here, a dot here, and a dot here. We'd make an egg shape with those 4 dots. But that's if we had plus in the middle, huh? It's almost the same. It's almost the same with the hyperbola. When you have a minus in the middle, you do the same 4 dots. That's all the same. But instead of making an egg shape connecting those 4 dots, an ellipse, we're going to make a dotted box. So go ahead on your paper, make a dotted box, so not an egg shape, not not an ellipse, but a dotted box through the same 4 dots, though. Same 4 dots. What's underneath x? Right, left 1. What's underneath y? 9, 3 squared, 3, up, down 3. So we're up 3, down 3, right 1, left 1. And we make a dotted box instead of a egg-shaped ellipse. So now, now remember, anything dotted on a graph isn't really there. It's just like a guideline or something to help you draw what really is there. It's like scaffolding on a building, right? They put up scaffolding so they can build the building. When they're done, they tear it down. It's just there to help you get the building going. So this dotted box is just there to help me get the real branches in place correctly. How do I do it now? What's with the dotted box? Anybody know? Anybody done this before? Shoot the diagonals through. Thank you. Sorry, I'm in the middle of that here. I'll pause. Okay. So is everybody good with this? Let me finish this up right here. Boom this way, boom this way, boom this way, boom this way. And the branches are right, left. So there we go. That's the real graph, huh? The other one, so it is going to be B, because you can see these branches are real tall, right? See how the branches are real tall? If you did D, we know it's not D because, here, I'll scribble it in up here. We know it's not answer D because that would be x squared over 9 minus y squared over 1 equals 1. So that's, right and left 3 and only up 1, down 1, right? Left 3. Right 3, because what's underneath x is 3 squared, y is 1 squared. So that would be a box that only goes up 1, down 1, right and left 3. So the branches would be really narrow. And so the like this, they'd be like that, wouldn't they? Everybody see the difference? So it's not D, that's a mess. It's not D, it's
Why
B.
did you cross out B?
So, yeah, why did I cross out B? B. B it is. We good?
Yeah, we're good.
All right, you got it. You're like, we got it. What does transverse mean? What does trans mean when it's in front of a word? Trans. My high school senior English teacher, just a couple years ago, I think, 1985, had us memorize prefixes and suffixes. I hated it at the time, but she was right. It helps you know a lot of words. Trans means across. Trans in front of any word means across. If you know prefix suffix, you know a lot of words pretty quickly. That's sometimes all they are is put together those. Anyway, so let's do the thing, and then remember that's across. So we'll get to the meaning here. So the center is 0, 0. Center is 0, 0. The focus is 10, 0. So let's put that on there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom, right there. There's the focus. And if one of the focus points is at 10, 0, guess where the other one is? Negative 10, huh? 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the other focus point at negative 10, 0. And where are the focus points on these? My graph doesn't look even, does it? But anyway, where are the focus points on these graphs always? They're always inside the branches, aren't they? And that continues to be the case. That's always the case. So that means the branch, well, here they're telling me vertex is 6, 0. 1, 2, 3, 4, 5, 6, 0. So there's the vertex at 6, 0. The vertex is, which means it goes that way. And the other vertex must be back 6, going that way. Does that make sense? On the graph, the focus points are always inside the branches. The vertex points are where the branches hit, aren't they? So same words we use for ellipse. The branches have just turned away instead of towards each other. Okay, and so what does that mean then? What's their question? Transverse axis. Trans means across. So what axis cuts across?
The x-axis.
Yeah, you can see the x-axis is cutting across them. No, they both hit the x-axis, huh? So that's what they're asking. Which one cut? It's also the axis of symmetry. Well, so in this one, so is the y. Yeah, so never mind. We'll keep moving. Anyway, equation now. We need an equation. Can we get the equation of that hyperbola, those two branches?
Yeah.
What's the equation going to be? So who's going to come in the front, x or y? X. So it's going to be x squared over a squared minus, right? It's a negative relationship. The branches have turned away from each other instead of plus in the middle. It's just like the hyperbola equation. So what do you think? Do we know the A? Do we know what's underneath X? Do we know right and left? Remember, X is always right and left. Yeah, from the 0, it's right 6, left 6, huh? Good, so that's 6 squared. Good so far, just like we would for an ellipse. No difference. Now, how are we going to find B, though? I don't know how far up and down. I don't have the dotted box here. I don't know.
The little X thingy like that. I haven't figured it out with the box.
Remember what we did yesterday? Whenever we had A and we tried to find B,
Yeah, subtraction.
we would always use the Pythagorean Theorem. The focus equation, remember that? That's what you did in last night's homework on this from the ellipse, right?
Yeah.
Sorry, I'll just quit kidding you about that. All right. So remember the focus equation? The hyperbola one's same except opposite sign in the middle. So yeah, let me help you. I mean, you don't have to memorize it, but it'd be nice and convenient. It's a squared plus b squared. And that will be the focus. So that's what's nice. It's exactly, see how the hyperbola equations exactly the same in the ellipse, except all signs reversed, remember? And the ellipse, the original one was positive, and the Pythagorean one was minus. Remember for the ellipse? But for the hyperbola, they're both switched. So it's minus in the main, plus in the focus equation. So the focus equation is always opposite sign from the original, both for hyperbola and ellipse. See how that's the same thing? And then you just solve it from there. Okay, so now... so we've got, and by the way, the Pythagorean one is easier to work with the hyperbola. This is the easiest of all the shapes. Because what? Because this is added here, so you don't have to worry about which one's bigger and smaller. Remember how we're kind of stressed about that, the bigger one first? They're added. So who cares who's first and second? The order doesn't matter at all. Just A and B, whatever, who cares? Don't even have to think about it. Whereas with the minus, we always had to worry about putting the bigger one first. So yeah, just whatever, 6 squared plus b squared is c squared. Oh, and what's c? C is always the focus. Where's the focus? 10, totally. C is 10, that's the focus. So that's 10. So that's 36 plus b squared's 100. Minus 36. Minus 36, b squared is 64. B is 8. So there we go. Put the b in is 8. We got the equation. We're done. And we have the graph too.
How come you made it minus? Isn't it supposed to be plus?
It's minus in the original, and it's plus in the focus. Am I answering your question?
Yeah.
Minus for hyperbola, minus in the original, plus in the focus equation. Always reverse in the focus equation. Good on that. I don't know how picky they're going to get with you about the answer. Well, maybe I should do one of them. Let's do x squared over 6 squared. Let's go. But it's all good. You're up to bat. You get 3 pitches. Just swing it a couple. But in the test you don't, right? So.
You should.
Yeah, 3 tries. Okay. So we got to figure out. So you're going to have to do the box to figure out how wide or narrow, right? So let's do it. I'll do it one more time real quick. X squared over 6 squared minus y squared over 8 squared is 1. So what's it going to be? I bet it's going to be, can you make an educated guess right now?
It's always B.
I think it's D. I could be wrong. But these are close to each other. These numbers are 6 and 8 are pretty close, you know? So it's going to be pretty diagonal. You know what I mean? Because it's going to be like over 6, up 8. It's going to be, whereas like, see how this is pretty tall?
Yeah.
Let me show you what I mean. You'll get the hang of it once you've seen a couple of them. So let's make the box. What do? You go over 6, because X is always right, left. Again, don't worry about A, B stuff. Just X is always right, whatever's under X is always right, left. Y is always up, down. So go right 6, 3, 4, 5, 6. Left 6, 3, 4, 5, 6. And then go up 8, 1, 2, 3, 4, 5, 6, 7, 8. And down 8, 4, 5, 6, 7, 8. So up 8. So you see how the box ends up fairly squarish? Squarish, a word? Kind of square. And so, so therefore the diagonals are pretty kind of like right in the middle.
Enclosed.
Yeah, they're like that. They're not bent really tall or really flat. That's what I mean. They're not super tall or super flat. They're pretty much middle, because 6 and 8 are kind of close to each other, right? Whereas if I had a box that was real squished, remember that one that's right there, then the diagonals end up being real flat, don't they? Or if the box is real tall, the diagonals end up really tall, and you get big branches. So I'm thinking we're going to get kind of medium branches, right? Oh, it's right, left. So yes. So start in the middle, Go up and down to the branches. Looks kind of middle to me. Yeah, I don't think B is right because B looks like the branches are taller than they are wide. And our branches are, well, it is a little, but it's close. It's a little bit close.
You should just make those like 2 chance on the test. So
Well, I'll make sure it's not that able to fool you because that's kind of close. Can you tell?
just put B.
I think it's B.
Yeah, so it's not D. So you didn't need to draw all the box stuff, did you? That's not needed. The problem, you can't tell here, but D is at 8, so it's not D. The answer's B.
You're obviously not going to do that on a test to make it that confusing.
Not unless I'm in a really bad mood. I don't know. No, I'm just kidding. No, I won't.
Easy.
Bro?
You ever had someone, one of your students cut you off?
Not that I can remember. Have you been cutting off a lot of your teachers on the road?
No. That's not what you do.
There's Mr. Jones. Mr. Jones. All right, sorry. You're getting me distracted, Ro. I'm trying to be serious today. All right, so there we go. X squared over 9 minus y squared over 49 equals 1. We're supposed to do everything on this one. So what's the center? So far, they haven't moved them. They're going to in a minute. They're going to move the center. How do I know they haven't moved the center? What do they do with an equation, any of these equations, when the center's been moved? You'd have x plus a number or y minus a number, right? Numbers added or subtracted next to y in parentheses, opposite's the center. So right now it's just 0, 0, isn't it? So far they haven't moved them. They'll do that in a minute. So the center right now is 0, 0. Okay, so the center is 0, 0. Okay, what's underneath the 9? The x is 9, 3 squared. So right 3, left 3. And 7 squared, up 7. Down 7. Like that. Make the dotted box. Okay, put in the diagonals, right? Let the diagonals shoot out the corners. Okay, so there it is. Now, are the branches on this one right, left, or up, down?
Right, left.
Yeah, every one we've had so far has been right, left, because X is in the front yet again. So you start in the middle, and you go up, and you go down to the branches, middle, up, and down to the branches. There we go. Okay, let's pick all this stuff. What's the transverse axis? The axis that cuts across. Yeah, again, it's X. It's just, these guys are hitting the X-axis, aren't they? Both branches, they don't touch the Y-axis, okay? Next question, what are the vertices? The vertices are where it hits, huh? So right here, 3, 0, and minus 3, 0. Good on those? That's this point and this point. 3, 0, minus 3, 0, the vertices. If the branches were going up, down, then the vertices would be that top and bottom, because they would hit right there. Good, okay. Next come the foci. How do we find the two focus points? Focus equation, Pythagorean. A squared plus b squared is, we use the plus. Right here, let me rewrite it for this one. A squared plus b squared is c squared. That's the focus one. So a squared plus b squared is c squared. So, right, because if it's minus in the main, it's plus in the focus. It's always reverse sign. So, right, for the ellipse, it was plus in the main, minus in the focus, wasn't it? It's always reverse. Okay. So what's the A and the B? Order doesn't matter. Again, that's nice. You just, whatever. Who cares? X, Y, whatever. Well, one of them's 3. The other one, 3 squared, and 7 squared, huh? So 3 squared and 7 squared, whatever order, who cares, is c squared. So that's 9 plus 49 is c squared. So that is, what's that, 58? Yeah, 58. So c squared is 58. C is the root of 58. Can that be simplified? I don't think so. It's 2 times 29, isn't it? 40, yeah. And 29 can't break down. So there's not 2 of anything, so you can't ship anything out of the root. It just stays root 58. So what does that root 58 mean? Well, that's how, remember, C is always how far from the center to the focus, and the focus is always inside of the two branches, huh? For all the shapes, the focus points are inside. Lewis?
Where are since we're using the Pythagorean Theorem, that means that we're using triangles. Where are the triangles on the graph?
Good question.
How do we find the triangles?
Well, actually, that's not true. A squared plus B squared equals C squared can be used for a triangle. It is true for a triangle. It's also true for other things. So it's not because it's a triangle that it's A squared plus B squared is C squared.
Triangles involved.
It's because of the relationship. So I haven't really shown you how remember how I showed you that if you have a line and a point, all the points equidistant, that produces a parabola. And if you have 2 points, all the points have the same total sum, and you do your pin around, you get the egg shape. Well, I haven't said anything about how the two focus points generate the hyperbola branches. It has to do with that relationship. It's kind of complex. Basically, what it is, the two focus points, you take all the points that have the same difference in distance. There's a minus in the main hyperbola equation. Difference of distance between the two. That's kind of a confusing statement. In other words, you say, what are all the points? Like if you'd say, this point, say, is 2 away from this focus, and say it's 7 away from that focus. So the difference in distances, this point is 5 different in distance between the two focus points. And if you come up here, maybe this is, 1.5, and this is further. This is like 7.5. So the difference is still, what would it be? I don't know. Anyway, I'd have to go through a whole, come to office hours. Be glad I can actually derive the formula for you, and we can talk all about it. But that's where it comes from. That's where the A squared plus B comes from, for the relationship of how the focus points generate the two branches. And what the rule is for a hyperbola is all the set of all points that have the same difference in distances between the two focus points. Ellipse was the sum. Yeah, right. Enough said on that. And so let's go back. So we got C is the root of 58. So that means this is root 58, 0. And this is, get this out of the way. This is minus root 58, 0. This point here is the minus 3, 0. Everybody with me on that? Those are the two focus points. Is that okay? So the Pythagorean Theorem, A squared plus B squared is C squared, generates the two focus points, square root of 58. It's always inside the branches. Okay, so what does that mean? Now, well, what do we have left? So we got the focus. Last thing, asymptotes. Asymptotes. So I've got to come up, let me make some room up here. I got to come up with what the asymptotes are for this shape. Now, the asymptotes are actually very easy to deal with if you think about it a certain way. Let me give you that way, obviously. That's my job. So the asymptotes, here's what it is. Asymptote, this dotted line right here, we're talking about what we mean is, what's the equation of that dotted line, and then the other one is going to be the same thing, negative. So what's the line? That's a line, isn't it? This is a line. What's the equation of that line? Yeah, that's a y equals mx plus b kind of thing. Wouldn't you all agree? Mm-hmm. It's got a slope, right? That dotted line, that asymptote line, is a diagonal line. It's a straight line. Well, the equations of straight lines are y equals mx plus b, aren't they? Now, what's the b? Remember from your algebra days, y equals mx plus b? What is the b? It's where you start. Yeah, where's this one start?
0.
0. So that's just gone. It's just 0. So really the equation is simply just y equals mx, isn't it? It's just some kind of slope times x. The y-intercept is 0. The b is 0. So all I need is the slope. And I got it. That's all it is y equals some kind of slope times x. What's slope? Rise over run. Right? Well, what's the rise and run?
7/3.
Yeah. See how easy it is? We know 7, we know 3. Because that's how we made the box. In other words, look right here, look right there. That quick. 7 over 3x. Give a little more room there. 7 over 3x. Does that make sense? So notice you can do this without doing anything. You can just look at the original equation and go 7 squared, because that's under y. So y's rise, y's up, down. Just go rise over run, 7 over 3. It'll always work like that. 7 over 3, right? Because this goes up 7 over 3, doesn't it? Up 7 and then over 3. And now, that's for the line that goes up. What about the other one that goes down?
It's negative.
It's negative. It goes down 7 over 3. So in other words, both of them together, plus or minus 7/3 x. It's always that way, plus or minus. Plus for the one going up, minus for the one going down. So the two asymptote lines are plus 7/3 x and minus 7/3 x. So what they have you do is just write plus or minus 7/3 x. There's the equation of the two asymptote lines. Just rise over run. Just whatever's underneath y over whatever's underneath x. Rise over run. Good? So we did everything on that one. Okay, so there's our equation. 9y squared minus x squared is 9. And they want everything from us. So what should we do first? It doesn't have the look we need to graph it. So what do we got to do to, what look does it need?
X squared and minus y squared.
Right side has to be? 1. For ellipse, last section and this section, right side has to be 1. For parabola, it had to be 4, the stuff, right? But we got to get, so we divide through by 9. We get y squared minus x squared over 9 equals 1. So now it has the look we need. You always have to get a 1 on the right side for both ellipses and hyperbolas. Okay, can you graph it from there? Let me give you a second. Let's go ahead and graph it, see if you can answer their questions. Now that it's got the right format. Practice exams, I almost got it up last night, and I'm having trouble with my Google site. So I'm going to get it up by tonight. I'll guarantee by tonight the practice exam number 3 will be online, so you'll have it this weekend to look over. It's literally all made and on my computer, and I just couldn't stick it on the website. For some reason, my Google sites was doing something weird. I always have technology problems. My problem is they keep changing everything. And I'm old now. I don't like change. And they go, well, this always worked. I just click here. Why isn't it working? Because they've updated it, and it's new and improved now. And I can't do it now. I'm an old dog, and I get tired of the new tricks. I just waste my life fiddling with stuff with technology. All right. So this is over 1. So this is 3 squared, 1 squared. Let's go to the graph. So that means up 1, down 1. And right 3, left 3. And then you put the box. Right, and then run the diagonals through. So these are going to be very flat diagonals, aren't they? Like that. All right. And then go to there. Now, how are the branches? Up, down, or right, left?
Right, left, down.
Up, down, because y is in the front this time, huh? We got y in the front, so it starts in the middle and goes very wide. And like that. That makes sense? Very, very wide branches, it turns out. My drawing is a little sloppy. It's supposed to be hitting right here. It's terrible. And so they get closer to those branches forever. That's what an asymptote line does, huh? It's a guideline, a line of approach. So closer and closer and closer forever to that line, until it's basically just right on that line. Okay, so there we go, branches up and down. So what's next? What do they want? They want the center, they want the transverse. So what's the center? It's 0, 0. What's the transverse axis? What axis does it hit? The y-axis on this one. Whoever's in the front, huh, is the transverse axis. Y is in the front. Okay, what are the vertices? What are the places it hits the axis? Here and here. Over 0, up 1, over 0, down 1. Those are the vertices. What are the foci, the two focus points? Did you find those? Let me get this out of the way. Yeah, so you got to do the little focus equation, the Pythagorean. So let me write. So our equation is y squared over 1 minus x squared over 9 equals 1. So the focus is a squared plus b squared is c squared. That's the focus. So what is it? 1 plus 9 is c squared. Right? And so that's 10 is c squared, root 10. C is root 10?
Yeah.
So now where are the focus points? Up, down, or right, left? Yeah, it must be up here and down there because they're always inside the branches for all of our shapes. So this one is over 0 up root 10 and over 0 down root 10. There's the two focus points. 0 root 10, 0 minus root 10. Good? For the two focus points. Finally, the equations of those two asymptote lines. That's the easiest thing in the world. Rise over run, plus or minus rise over run x. It'll always be that. So y equals plus or minus. What's the rise? 1, and the run is because 1 is what's under y. Whatever's underneath y is always up, down, rise. And what is underneath x? 3 squared, 3, is run x. Here we go, plus or minus 1/3 x. Good? Easy enough? All right. Number 12. So number 12, let's do one that's been moved. So the center is at 6 minus 6. So let's draw that. 1, 2, 3, 4, 5, 6. So right there. Over 6, down 6. So there's the center. The focus is at 9. Move that over. The focus is at 9. So here's the center. 6. The focus is at 9. And the vertex is at 8. Ooh, they're tight. Right there. There they are. Everybody see that? So the vertex of the center. I better space that out a little bit more, huh? Here, let me space. I didn't know they were so tight. Let me space that out a little bit more. And see if I can help that. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9. There's 8. There's 6. 1, 2, 3, 4, 5, 6. There's down 6, so it's over 6, down 6 is the center. And there's the vertex. There's the focus. So we get to there for starters. So, is this thing, and that's it, it's all they give me. From that, I have to come up with everything. So first thing to decide is it branches right, left, or up, down? It's right, left. How do we know it's right, left? That's correct. It's right, left.
Because the 6 is not changed.
Yeah, the focus is always inside. So it must be hitting at the vertex going that way, and then another one this way. Now, how far? Well, this is 1, 2. So this will also be 1, 2 back at 4, huh? From 6 to 4, 6 to 8. So right here. And then the focus must be back at 3, because it's 3 that way to the focus, 3 that way to the focus. Everybody good with that? It's got to be like that, doesn't it? Good? All right, so let's write the equation. It's going to be, so who's going to be in the front, x or y? Going to be x. It's like that first off. That's the general shape. But we got several things we need to fix about that. The center is not 0, 0. So what's the center? It is 6 minus 6, and it's opposite, opposite. So x will become, this is x, this is y, x minus 6 squared, and y will become y plus 6 squared. Good so far? That's what we always do for the center. Now what about the a and the b? Well, a is what's underneath x, so what's a? Can you tell?
2, right?
Yeah, A is how far to the right? 2 to the right, exactly. And 2 back. So A is 2 squared. So we can make that 2 squared. How are we going to get B?
The Pythagorean Theorem.
The Pythagorean Theorem. Because we know this is 3 for C, huh? How far to the focus? So A squared plus B squared is C squared. That's always the focus. So C is 3 squared. 2 squared plus B squared is 3 squared. 4 plus B squared is 9. B squared is 5. B is the root of 5. So B squared is root 5 squared. In other words, it's just going to be 5 there, huh? There's the equation. We got it. All right, we're out of time.